Dear students, in this video we are going to discuss about dielectric polarization. So first of all, we will discuss about dielectric. What is dielectric? Dielectric are those substances which are similar to insulator, but when we placed dielectric inside the electric field, they get polarized. To understand the process of polarization, first of all, we should understand about dielectric. There are two types of dielectric. First one is polar and second one is non-polar. So one by one we will discuss about the type of dielectric. So we have two type. First one is non-polar, that is your non-polar, and the second type is polar molecules. So this one is your polar molecules. So what is the difference between the two? We will discuss that difference. In the non-polar molecules, the positive and negative charge coincide with each other of the atom. All that, as we know, all the dielectrics are made of atoms and molecules. So in case of non-polar molecules, the charge, positive charge and the negative charge of the molecules lie at the center of the molecule. In that way, positive and negative charge at the same place. Example, you can take example for non-polar is your hydrogen atom, nitrogen, oxygen. All these are your non-polar molecules. Similarly, in the polar molecules, they arrange themselves in the shape of a dipole. Positive and negative charges are separate in case of polar molecules. Example, we can take water. In case of water, oxygen one side and hydrogen other side, and the third side hydrogen, H2O. So hydrogen has a positive charge and oxygen has negative charge. So in this way pole are formed in this case and this case. So that's why we call these molecules as a polar molecules. So the property of polar molecules and non-polar molecules help us to understand the process of polarization. In case of polar molecules, when positive and negative charge is separated but both the charges are equal and opposite, so net field is 0. Similarly, in this case, electric field will be 0. This condition is satisfied when there is no external field, but the internal field of these molecules is 0. Now, we will understand this process by taking the example of a dielectric materials. First dielectric material we will take non-polar molecules, and in the second material we will take polar molecules, and one by one we will understand that process. So first of all, I will take the example of non-polar molecules. So let us consider I have a dielectric substance. This is our dielectric substance, and molecules in dielectric substance, as we know, the molecules in the dielectric substance are arranged in this way. Positive and negative charge lies at the center, coincide, both charges coincide with each other. So in this way we can draw a non-polar molecules dielectric, positive, negative, positive and negative. Now what is the difference in this case? In this case we place this dielectric substance inside the electric field. So E is the electric field here. So what will happen to the dielectric substance molecules when you placed in the electric field? First of all, because as we know the electric field direction is positive to negative, so due to this electric field, all the negative, when you placed in the electric field, what will happen when you place this molecule in the electric field, what will happen, these molecules will arrange themselves in this way: negative and positive, negative and positive, negative and positive. So this is due to the effect of this external electric field, because we placed the molecules in the external electric field. We can do one thing, I draw this electric field here. It's better to draw this electric field here. So the diagram will be more clear. So this is your external electric field. In this case, field is 0. There is no external field. Okay, but here E0 is the external field, and this field try to attract these negative molecules toward this positive side, and this way all the molecules get polarized. They separate their poles. So this is the polarization process in case of non-polar molecules. Similarly, we will understand the same process in case of polar molecules. So again, for the polar molecule, now I will discuss about polar molecules. So again, the same example I will take. I have two cases. This is your dielectric substance having polar molecule. So how to draw the polar molecules? Polar molecules are arranged randomly. There is no regular manner for the polar molecules. This is the condition when there is no external electric field. So here the electric field is 0. But what will happen when you place the same dielectric substance inside the electric field? What will happen? So when you place this substance inside the electric field, all these molecules will arrange themselves in a proper order. So all these will arranged. Here is your electric field E, as we know, start from positive and exit at negative. So in this way, negative charge is attracted by positive charge. So negative, positive, this is your negative, positive, and negatively charged, positively charged. So all the molecules arranged themselves in a ordered manner. Earlier they are randomly arranged, but when you placed all these molecules in the external field, they all arranged in a particular ordered manner. So because of this external electric field, there is a field developed inside these molecules. That field is internal field. That field is because of the polarization. In the same way, here also internal field is developed, that is your polarized field EP. So in this way, when you placed a dielectric substance inside the electric field, so because of the polarization property of the dielectric substance, internal polarized field develop inside the dielectric substance. So I hope this topic is clear to you. If you like the video, please don't forget to subscribe my channel, and for any query you can comment below this video. Thank you.